Right now, every galaxy in the observable universe is drifting away from every other galaxy, not toward any edge and not away from any center, but outward in every direction at once. 93 billion light years. That is the current diameter of the observable universe. A number so large it has no sensible comparison. It simply is. We are taught that every explosion has an origin point, a place where the blast began and from which all debris flies outward. The universe began in an explosion of sorts, and yet there is no origin point. There is no center. There never was. In 2005, cosmologists found a direction in the oldest light in the universe, a faint alignment that shouldn't be there, a whisper of structure in a cosmos that isn't supposed to have any preferred direction at all. We still don't know what it means. Tonight, we will trace the long, quiet history of this idea, from the first astronomers who assumed Earth sat at the middle of everything, to the space telescopes that prove no middle exists at all, and finally to the strange calm peace that follows when we stop looking for one. Now, let us begin. There is something almost stubborn about the human desire for a center. We grow up inside it. The rooms of childhood have middles. The schoolyard has a flagpole. The town has a square. Even the stories we tell ourselves have centers, a protagonist, a turning point, a heart of meaning around which everything else orbits. So it is entirely natural that when human beings first looked at the sky, they placed themselves at the middle of it. And for a very long time, that felt correct. The sun rose on one side and set on the other. The stars wheeled overhead in tiny circles. The earth felt still. It felt heavy. It felt permanent. Everything else seemed to move around it. That was not a foolish conclusion. It was a reasonable one, drawn from the best evidence available at the time. But tonight we are going to follow a different thread. Not the story of how we lost the center, although that story is woven through every chapter. Rather, we are going to follow the quieter, stranger realization that came afterward. The realization that no one lost the center, because there was never one to lose. The universe has no center. At least, that's what mathematics says. But the data has been whispering something else. Tonight we follow both threads. That sentence sounds simple. You may have heard it before, but most of us, when pressed, cannot quite explain what it means, and even fewer have sat with how it feels. It is not a sad idea. It is not a lonely one. It is, as we will discover, something much closer to a lullaby than to a loss. But we will get there slowly. Over the next 90 minutes or so, we will travel backward in time to ancient Greece, where the first geometric models of the cosmos were sketched in sand. We will visit medieval Europe, where the idea of a cosmic center was inseparable from theology, from hierarchy, from the very structure of meaning. We will stand beside Copernicus, who moved the center from Earth to the sun and thought he had solved the puzzle. We will watch as telescope after telescope pushed the center further away from our planet, from our star, from our galaxy, until at last there was nowhere left to put it. And then we will do the most interesting thing of all. We will sit with the result, because the absence of a center is not an absence of meaning. It is paradoxically one of the most democratic truths the universe has ever offered. Every point in the cosmos has an equal claim to the middle, including the one beneath your pillow right now. But that is later. For now, all you need to know is this. We are going somewhere tonight, and the path is gentle. The question we are answering is plain and specific. Why does the universe have no center, and what does that tell us about where we are? Not where we are on a map. Not where we are in a city or a country. Where we are in the largest possible sense. Where we are in the structure of everything that exists. It is a question that sounds like it belongs in a physics lecture, and it does. But it also belongs here, in the dark, in the quiet, right before sleep, because the answer is not frightening. The answer, once you hear it fully, is one of the most restful things science has ever found. No center means no periphery. no edge of importance, no hierarchy of place. The view from here is just as valid, just as central, just as real as the view from any other point in the cosmos. You are not on the outskirts of anything. You never were. And so tonight, as the chapters unfold, you may notice something peculiar happening to the usual anxiety that comes with thinking about the size of the universe. It may begin to dissolve, not because we are ignoring the scale. We will face the scale directly, with real numbers and real distances. But because the scale, once properly understood, is not a threat. It is a context, and context, when it is honest, tends to bring peace. So settle in. Let the sheets do their work. Let your breathing find whatever rhythm it wants. There is no rush in this documentary because there is no rush in the universe. The expansion is patient. The light is patient. The distances are patient. And we can be patient too. Let us begin with the people who first tried to find the center. Let us see what they found and what they didn't, and how each failure opened a door to something larger and more beautiful than the center they were looking for. The night is long enough. The story will carry you. Chapter 2. Why it matters that nowhere is the middle. Before we go back in time, before we trace the lineage of this idea through centuries of stargazing, let us pause on something that might seem unnecessary but is not. Let us ask why this matters. Not to science. Science has its reasons, and we will explore them in full. But to you, to a person lying in the dark, breathing softly, wondering whether to stay awake for this or let it wash over you like a tide. Why should it matter that the universe has no center? Here is one reason, the simplest one. Almost every source of cosmic anxiety comes from a sense of displacement. We learn the universe is large, and we feel small. We learn the Earth is a speck, and we feel unimportant. We learn that the sun is one of hundreds of billions of stars, and something in us deflates. That deflation has a hidden assumption inside it. The assumption is that importance is geographic. That meaning is assigned by position. That to matter, you must be near the middle of something. Kings sit on thrones at the center of courts. Capital cities sit at the center of nations, or at least we imagine they do. The main characters stand center stage. So when science says that Earth is not at the center of the solar system, and the solar system is not at the center of the galaxy, and the galaxy is not at the center of the universe, it feels like a series of demotions. Each discovery seems to push us further from significance. But here is the correction that most popular science never quite delivers. It is not that we were moved from the center to the edge. It is that the center was removed entirely. There is no middle to be far from. And this changes the emotional math completely. If there is no center, then there is no periphery. If there is no throne, then no one is banished from it. The whole framework of cosmic importance by location collapses, not into despair, but into equality. Every point in the universe is, in a very precise and physical sense, just as central as every other. The cosmic microwave background, the oldest light in existence, surrounds every observer equally. The galaxies recede from every point in the same pattern. The laws of physics operate identically, whether you are here or in the Andromeda galaxy, or in some unnamed void between superclusters a billion light years away. This is not poetry. This is measured, tested, confirmed physics. And its emotional consequence is profound, even if no textbook says so. You are not on the outskirts. You are not clinging to an unimportant rock at the edge of nowhere. You are at a point in the universe that is exactly as central as any other point, because centrality, in the old sense, does not apply. This matters at night especially. Night is when scale becomes personal. Daytime science is intellectual. You can read about billions of light years and nod and move on. But at night, when the ceiling is dark and the body is still, the numbers land differently. They become feelings. And the feeling that most people carry about the cosmos, The one that lives just beneath their everyday awareness is a feeling of smallness that borders on irrelevance. Tonight, very gently, we are going to replace that feeling. Not with false comfort, not with wishful thinking, not with spiritual language dressed up as science, but with the actual finding, the actual measured peer-reviewed discovery that the universe treats every location the same. You are not lost in it. You are woven into it. There's a difference. Lost implies a correct place you have strayed from. Woven implies that your place is part of the pattern, indistinguishable in status from any other thread. This is what the cosmological principle says in its quiet, mathematical way. On the largest scales, the universe is homogeneous and isotropic. The same everywhere. The same in every direction. Homogeneous means that if you could teleport to any other point, the view would be statistically identical. The same density of galaxies. The same temperature of background radiation. The same rules. Isotropic means that no direction is special. There is no up in the cosmos, no preferred orientation, no arrow pointing toward the center because there is no center to point toward. These are not philosophical positions. They are observations, confirmed by decades of microwave surveys, galaxy counts, and redshift measurements. And they carry a gift, if you are willing to receive it. The gift is rest. Not the rest of ignorance, but the rest of understanding. The rest that comes when you stop trying to find your place in a hierarchy that does not exist. You do not need to earn centrality. It is not withheld from you. It is simply not a feature of the cosmos you inhabit. And once that sinks in, really sinks in, past the intellect and into the body, something loosens. The universe is not ignoring you. It is not relegating you. It is not structured in a way that even allows for relegation. It is structured in a way that makes every vantage point equivalent, including yours. Right now, tonight, this is the emotional foundation we are building before we tell the history. Because the history is full of people who were terrified to lose the center. They fought against the idea. Some of them died for it or because of it. And what we want to understand is not just what they discovered, but what they were afraid of and why the fear was, in the end, unnecessary. The center was never ours to lose. It was a story we told about the sky, and like many stories, it was eventually outgrown. What replaced it is larger, stranger, and far more generous. Let us go and find it. Chapter 3. The ancient longing for a middle. The oldest astronomers did not have telescopes. They had eyes, patience, and an overwhelming desire for order. And what their eyes showed them was a sky that moved. The stars rose in the east and set in the west. The sun traced an arc. The moon drifted through phases. The planets, those strange wandering lights, looped and reversed against the fixed backdrop of constellations. Everything moved. Everything except the earth beneath their feet. It is easy, from our century, to condescend to the ancients, but their conclusion was perfectly logical. If you feel no motion and you see everything else moving, the simplest explanation is that you are still. And still means central. The earliest cosmologies from Mesopotamia, from Egypt, from China placed the Earth at the center of a layered cosmos. The sky was a dome or a series of shells. The gods lived above. The dead lived below. And the Earth, solid and flat or gently curved, sat in the middle of it all. This was not just astronomy. It was architecture. It was theology. It was identity. To be at the center was to be the point of the whole exercise. Then came the Greeks, and with them, geometry. Around the 6th century before the Common Era, thinkers in Ionia and later in Athens began to ask a new kind of question. Not just what moves, but how it moves. Not just where the gods placed us, but what shape the cosmos might actually be. Pythagoras and his followers proposed that the Earth was a sphere. This was not a guess. They had evidence. The circular shadow Earth casts on the moon during an eclipse. The way ships disappear hull first over the horizon, the changing positions of stars as you travel north or south. A sphere, elegant, symmetric, and, to the Greek mind, perfect. Perfection demanded a center, and the center was obvious. The heavy Earth, being the most material of all things, naturally sank to the lowest point. The lowest point of a sphere is its center. So the Earth sat at the center of the cosmos not by accident, but by nature. Above it, the moon, the sun, the planets, and the stars each occupied their own crystalline sphere, rotating in perfect circles. This model reached its most refined form in the work of Aristotle, around 350 BCE, and then its most mathematically detailed expression in the Almagest of Claudius Ptolemy, around 150 CE. Ptolemy's system was a masterpiece of geometric ingenuity. It accounted for the apparent backward motion of planets using a clever device called the epicycle, a small circle riding on a larger circle, like a teacup on a carousel. It was complicated. It required constant adjustment, but it worked. It predicted eclipses. It tracked planetary positions with reasonable accuracy, and it kept Earth firmly at the center. For 14 centuries, this model held. It held through the fall of Rome. It held through the rise of Islam, where scholars translated, preserved, and refined Ptolemy's work with extraordinary care. It held through medieval Europe, where the cosmic hierarchy, Earth at the center, God at the outermost sphere, became inseparable from Christian theology. The center was more than a location. It was a moral statement. Dante's Divine Comedy, written in the early 1300s, places hell at the exact center of the Earth, which is itself the center of the cosmos. Heaven surrounds the outermost sphere. To move outward is to move upward, is to move toward God. Every layer of the medieval universe had meaning. The moon's sphere separated the corruptible from the incorruptible. The stars were fixed in eternal, divine order. The Earth, mutable and fallen, sat at the bottom. In this framework, the center was not a place of honor. It was the lowest point, the heaviest, the most imperfect. And yet it was still the center, still the anchor, still the point from which everything else was measured. To remove Earth from that position was not just to rearrange the furniture of the cosmos. It was to collapse 1,000 years of meaning-making, which is exactly what happened next. In 1543, a Polish clergyman and mathematician named Nicholas Copernicus published a book. Its title, in English, translates roughly to On the Revolutions of the Heavenly Spheres. Its argument was simple. The mathematics of planetary motion become far cleaner if you place the sun at the center and let the Earth move around it. Copernicus did not have a telescope. He did not have new observations. He had the same data Ptolemy had, just rearranged. But the rearrangement was seismic. The Earth moved. The sun stood still. The center shifted. And for many, the ground beneath certainty cracked open. Copernicus himself was cautious. He dedicated the book to the Pope. He framed it, in part, as a mathematical convenience rather than a physical claim. He may have been genuinely diplomatic or genuinely afraid, possibly both. He died the year the book was published. He never saw the storm it would eventually cause. But the seed was planted. The center had been questioned. And once a center is questioned, it is very difficult to make it feel solid again. What followed was a slow, difficult, sometimes dangerous century of transition. Giordano Bruno would suggest that the stars were other suns with other worlds, and that the universe might have no boundary at all. He was burned at the stake in 1600, though the precise reasons remain debated. Galileo would turn a telescope to the sky and find moons orbiting Jupiter, phases of Venus consistent with a sun-centered model, and mountains on our own moon. Imperfections in a supposedly perfect sphere. The center was slipping, but no one yet suspected the truth that lay beyond the next horizon. They thought the argument was about which object sat at the middle, the Earth or the Sun. They did not yet realize that the real answer was neither. Chapter 4. The view begins to widen. Let us begin with a number, just to feel the ground shift. The distance from the Earth to the Sun is about 93 million miles. Light covers that distance in 8 minutes and 20 seconds. That means the sunlight on your wall this afternoon left the Sun before you finished your last cup of tea. That is close, cosmically speaking. That is a next-door neighbor. Now let us step outward. The nearest star beyond the Sun is Proxima Centauri. Its light takes 4 years and 73 days to reach us, not 8 minutes. 4 years. If the Sun were a marble on your kitchen table, Proxima Centauri would be another marble roughly 4 miles away. And between them, nothing. Just empty space, dark and silent, wider than any ocean on Earth. Copernicus had moved the center from Earth to the Sun, and for a time, that felt like enough. The Sun was glorious, bright, massive, the engine of all life. Surely it deserved the central throne. But the question of the center was not finished. It was only beginning. In the decades and centuries after Copernicus, astronomers began to take the measure of the sky with increasing precision. Johannes Kepler, working in the early 1600s, showed that the planets did not move in perfect circles, but in ellipses, slightly squashed orbits with the Sun at one focus, not even at the geometric center of the path. The perfection of circles, so beloved by the Greeks, gave way to something messier but truer. Isaac Newton, later in the same century, provided the engine behind Kepler's laws: gravity, a force that operated identically everywhere, pulling every mass toward every other mass with a strength proportional to their size and inversely proportional to the square of the distance between them. Newton's gravity was universal. It did not care about centers. It did not privilege one location over another. It simply described how masses moved in response to one another. This was a subtle but important shift. The physics itself had no preferred point. Still, the Sun felt central. The solar system orbited it. The stars seemed fixed and distant. Perhaps the Sun was at the middle of all the stars, a great fire at the heart of a vast cloud of lesser lights. In the late 1700s, the astronomer William Herschel attempted to map the shape of this cloud. He counted stars in every direction, reasoning that where he saw the most stars, the cloud extended furthest. His conclusion: the Sun sat near the center of a flattened disk of stars, a great lens-shaped structure with us comfortably in the middle. This structure would eventually be called the Milky Way, and for more than a century, the Sun's central position within it went largely unchallenged. But Herschel's method had a flaw, one he could not have known about: dust. Interstellar dust, fine grains of carbon and silicate scattered between the stars, absorbs and scatters visible light. It creates a kind of cosmic fog that dims distant stars and makes them disappear entirely in some directions. Herschel's star counts were not measuring the true shape of the galaxy. They were measuring how far he could see before the dust blocked his view. And the dust made it look like we were in the middle, even though we were not. The correction came in the early 20th century. In 1918, the American astronomer Harlow Shapley studied a particular type of star cluster called a globular cluster, a dense, ancient ball of hundreds of thousands of stars bound together by gravity. Shapley measured the distances to these clusters using a class of pulsating stars called Cepheid variables, whose brightness fluctuates in a pattern directly linked to their true luminosity. By comparing how bright a Cepheid appeared with how bright it actually was, he could calculate its distance. What he found rearranged the map. The globular clusters were not distributed evenly around the Sun. They were concentrated in one direction, toward the constellation Sagittarius. They formed a halo around a point that was tens of thousands of light years away from us. That point, Shapley argued, was the true center of the galaxy. The Sun was not at the middle. It was roughly 2/3 of the way out from the core, orbiting in the galactic suburbs. Another demotion, another center lost. But the question only deepened. Because even as the Sun was being displaced from the center of the Milky Way, a far larger debate was brewing. What was the Milky Way? Was it the entire universe? Or was it just one structure among many? Astronomers had long observed faint, fuzzy patches of light scattered across the sky, cataloged as nebulae. Some, like the Orion Nebula, were clearly clouds of gas within our own galaxy. But others, spiral-shaped smudges, like the one in the constellation Andromeda, were more ambiguous. Were they gas clouds inside the Milky Way? Or were they entire galaxies in their own right, vast and distant, separated from us by unimaginable gulfs of space? The debate came to a head in 1920 in what is now called the Great Debate. Held at the Smithsonian in Washington, D.C., Shapley argued that the Milky Way was everything, that these spiral nebulae were local. His opponent, Heber Curtis, argued they were separate galaxies, island universes far beyond our own. The answer came 4 years later. In 1924, Edwin Hubble, using the Great 100-inch telescope on Mount Wilson in California, identified individual Cepheid variable stars in the Andromeda Nebula. He measured their distances. The result was staggering. Andromeda was not inside the Milky Way. It was roughly 900,000 light-years away. We now know the true distance is closer to 2.5 million light-years. But even Hubble's initial estimate was far beyond the boundaries of our galaxy. The Milky Way was not the universe. It was one galaxy among, as we would eventually learn, hundreds of billions. The scale had exploded. Earth was not at the center of the solar system. The Sun was not at the center of the galaxy. And the galaxy was not the sum of all things. Each revelation was larger than the last. Each pushed the idea of a center further away, made it harder to pin down, made it feel less like a place and more like a wish. And yet, the deepest revelation was still ahead. Because in those same years, Hubble was gathering another set of observations, a pattern in the light of distant galaxies that would change cosmology forever and dissolve the very concept of a center once and for all. He was measuring how fast those galaxies were moving away from us. And what he found did not point toward a center. It pointed everywhere at once. But that is where the next chapter begins. For now, let the scale settle. Let the distances breathe. From a marble on your table to a point of light 4 miles away. From a suburb in a galaxy to a galaxy in an ocean of galaxies. The map keeps growing, and the center keeps vanishing. Rest here a moment. The story is patient, and so is the dark. Chapter 5. The trouble with everywhere at once. Let us return to Edwin Hubble in the light of distant galaxies. By the late 1920s, Hubble had gathered enough observations to notice a pattern. The galaxies were not sitting still. They were moving away from us. And the further away a galaxy was, the faster it appeared to recede. This relationship, distance proportional to recession speed, became known as Hubble's law. At first glance, it seems to suggest something simple and alarming. If everything is moving away from us, surely we must be at the center of the expansion. Surely we are the point from which all things flee. But that is not what the data shows. And this is where the story becomes genuinely strange. The expansion Hubble discovered is not like an explosion in a room. It is not like a grenade going off, sending shrapnel outward from a single point. It is something far more difficult to picture and far more interesting. The expansion is happening everywhere at once. Space itself is stretching, not into anything, not away from anything. The fabric of the cosmos, the distances between galaxies, is growing in every direction, at every point, simultaneously. This is the part that contradicts our intuition most stubbornly. We want there to be a center. Our brains are built for centers. But the mathematics of general relativity, Einstein's theory of gravity and spacetime, simply does not allow for one in a universe that is homogeneous and isotropic. Let us sit with that contradiction a moment. Here is a gentle way to approach it. Think of the surface of a balloon being slowly inflated. Draw dots on it with a marker. As the balloon expands, every dot moves away from every other dot. If you were a tiny creature living on one of those dots, you would see all the others receding from you. You would naturally assume you were at the center. But a creature on any other dot would see exactly the same thing. Every dot sees every other dot receding. No dot is special. No dot is the origin of the expansion. And here's the crucial part. The surface of the balloon has no center. Not on its surface, anyway. The center of the balloon is inside it, in a direction the surface creatures cannot point to, because they live only on the surface. In our universe, the analogy holds, but with one more dimension. We live in three-dimensional space, and the expansion is happening in all three dimensions simultaneously. There is no point within our three-dimensional space that is the center. If the universe has a center at all, it exists in a dimension we cannot access, cannot point toward, and cannot meaningfully discuss with spatial language. For all practical and physical purposes, the center does not exist. But this creates a genuine anomaly in how we think about beginnings. The Big Bang, as it is popularly described, sounds like an explosion. The name itself, coined somewhat mockingly by the astronomer Fred Hoyle in 1949, implies a bang. A single moment, a single point, a burst outward. And yet, the Big Bang did not happen at a point in space. It happened everywhere in space. All of space was the Big Bang. Every point in the universe was once the hot, dense, primordial state from which everything expanded. This is not a subtle distinction. It is the distinction. And getting it wrong is the source of nearly every misconception about cosmic centers. If the Big Bang happened everywhere, then no location can claim to be the site of the explosion. There is no crater. There is no ground zero. There is only the ongoing expansion, smooth and uniform, the same in every direction. But is it truly the same in every direction? Here is where the anomalies begin. In 2005, a research team analyzing data from the Wilkinson Microwave Anisotropy Probe, known as WMAP, noticed something unexpected in the cosmic microwave background, that ancient glow of radiation left over from when the universe was only 380,000 years old. The background is almost perfectly uniform, almost. But it contains tiny temperature fluctuations, variations of about 1 part in 100,000, which correspond to the seeds of all future structure: galaxies, clusters, moids. Most of these fluctuations behave exactly as predicted by standard cosmology. But some of the largest patterns, the ones stretching across the entire sky, seem to align in a way that standard models did not expect. This alignment was informally dubbed the axis of evil, a playful but provocative name. It suggested a preferred direction in the universe, a kind of cosmic arrow that should not exist if the universe is truly isotropic. Was this evidence of a center, a direction, a structure beneath a structure? The debate continues. Some cosmologists argue the alignment is a statistical fluke, the kind of pattern our brains find in randomness because we are evolved to find patterns everywhere. Others argue it is a real signal, pointing toward physics we do not yet understand. A related anomaly involves something called the cold spot, an unusually large, unusually cold region in the cosmic microwave background, located in the direction of the constellation Eridanus. It is about 70 microkelvins colder than average and spans roughly 5 degrees of sky. Several explanations have been proposed. It might be the imprint of a supervoid, an enormous region of space with fewer galaxies than average, which would drain energy from the microwave photons passing through it. It might be a statistical outlier, or it might be something else entirely, something that challenges the cosmological principle at its foundations. These anomalies are real. They are measured. They are published in peer-reviewed journals. But they are not evidence of a center. They are evidence that the universe, while overwhelmingly uniform, may have wrinkles we do not yet fully understand. The cosmological principle, the assumption of homogeneity and isotropy, is a large-scale statement. It does not claim the universe is perfectly smooth. It claims that on the largest scales, no direction and no location is fundamentally preferred. The anomalies live in the margins of that claim. They are whispers, not shouts, and they may ultimately tell us something new about the physics of the early universe, about inflation, about topology. But so far, none of them have restored a center. The center remains absent, and the search for it, in the data and in the mathematics, keeps returning the same quiet answer. Everywhere looks the same. No place is special. The expansion has no origin point. It is a strange kind of mystery. Not the mystery of something hidden, but the mystery of something missing that we keep expecting to find. Hold that thought gently. We are going to need it. Because next, we need to talk about the stories people tell when the science is too strange to sit with comfortably. Chapter 6. The stories we tell instead. There is a video that circulates online every few years. You may have seen it. It begins with a person standing on Earth. Then the view pulls back, past the moon, past the planets, past the sun, past neighboring stars, past the Milky Way, past galaxy clusters, until the entire observable universe is a faint circle on a dark screen. And at the very end, a small dot blinks at the center of that circle. You are here, it says. It is a beautiful video. It is well-intentioned. And it is, in one very specific way, misleading. Because the dot at the center of the observable universe is always wherever the observer happens to be. It is not a feature of the universe. It is a feature of the observation. The observable universe is not a place. It is a horizon. It is the limit of how far light has had time to travel since the Big Bang. And since light travels at the same speed in every direction, that horizon forms a sphere centered on whoever is doing the observing. You are always at the center of your observable universe. So is everyone else. So is a hypothetical astronomer in the Andromeda galaxy, or one in a galaxy 12 billion light-years away. This does not mean the universe has a center. It means every observer has a personal horizon, and they are always in the middle of it, by definition. It is like standing in a field on a foggy day. You can see the same distance in every direction. You appear to be at the center of a circle of visibility, but the field extends beyond the fog in every direction. The circle is yours, not the field's. This distinction is the source of perhaps the most common myth about cosmology, the belief that the observable universe diagram is a map of the universe with us at the center. It is not a map, it is a view. And the view is different from every vantage point, even though the view from every vantage point looks structurally the same. Another persistent myth comes from the language of the Big Bang itself. People hear explosion, and they think of something exploding outward from a fixed location into pre-existing empty space. They think of debris. They think of a point of origin you could, in principle, travel back to. But the Big Bang was not an explosion in space. It was an expansion of space. All of space. Everywhere. At once. There was no pre-existing empty room for the universe to explode into. There was no outside. There was only the expansion itself, carrying all matter, all energy, all of space-time with it. This is not a failure of language. It is a genuine limit of spatial metaphor. Our brains evolved to navigate three-dimensional landscapes, forests, plains, coastlines. We did not evolve to picture a space that is finite but unbounded, or a beginning that happened everywhere simultaneously. So we reach for the nearest metaphor, and the nearest metaphor is almost always wrong. The explosion metaphor gives us a center. The real physics does not. There is a third myth worth addressing gently, because it comes from a place of genuine searching. Some spiritual traditions and popular philosophies have taken the idea that every point is the center, and turned it into a mystical claim. The universe is conscious. You are the center because consciousness creates reality. Observation collapses the wave function. Therefore, you are cosmically central. These ideas borrow vocabulary from physics, but they do not represent what the physics actually says. The cosmological principle does not say you are special. It says no location is special. That is a very different statement. It is not an elevation. It is a leveling. And in its own way, the leveling is more profound than any elevation could be, because an elevation requires a hierarchy. Someone at the top, someone at the bottom. A leveling removes the hierarchy entirely. There is no top. There is no bottom. There is only the vast, even fabric of spacetime, stretching equally in every direction from every point. It is not mystical. It is structural. And it is, if you let it be, deeply peaceful. But myths persist because they serve emotional needs. The need for a center is really a need for orientation. We want to know where we are. We want to know that where we are means something. And when science says the universe has no center, it can feel like science is saying our location means nothing. That is not what science is saying. Science is saying that location, on the cosmic scale, is not a source of meaning. Meaning comes from other places, from complexity, from consciousness, from the relationships between things. The universe has no center, but it has structure. It has galaxies and filaments and voids. It has stars that forge heavy elements in their cores and scatter them when they die. It has planets with liquid water and magnetic fields and atmospheres that filter starlight into the colors of sunset. None of that requires a center. None of that is diminished by the absence of one. The myths about the cosmic center are not foolish. They are human. They are the mind's attempt to impose familiar order on unfamiliar reality. But the unfamiliar reality, once you stop resisting it, is more interesting than any myth. And it is to that reality, to what it means for telescopes, for navigation, for the human future, that we now turn. Let the myths rest. They have done their work. What comes next is what remains when the myths are set aside. Chapter 7. What changes when the center disappears? If the universe has no center, how do we navigate it? This is not an abstract question. It is a practical one, and the answer shapes everything from how we aim our telescopes to how we measure the age of the cosmos. Consider the Hubble Space Telescope, orbiting 600 kilometers above the Earth, circling the planet once every 97 minutes. When it turns its mirror toward a distant galaxy, it is not looking outward from a center. It is looking outward from one arbitrary point in an infinite, or at least unbounded, expanse. And yet, the observations work. They work because the laws of physics are the same everywhere. The speed of light is the same. The behavior of atoms is the same. The redshift of light, the stretching of wavelengths caused by the expansion of space, follows the same rules whether you observe from here or from a galaxy, halfway across the observable universe. This uniformity is not a convenience. It is a prerequisite. If the universe were not homogeneous and isotropic, cosmology as a science would be nearly impossible. We could not assume that distant galaxies obey the same physics as nearby ones. We could not use redshift to measure distance. We could not reconstruct the history of the cosmos from the light that reaches us. The absence of a center is what makes the universe legible. It is what allows us to take a measurement here and trust that it applies there. It is the reason a spectrum of hydrogen light from a galaxy 10 billion light-years away shows the same pattern of lines as hydrogen in a laboratory on Earth, just shifted toward the red end of the spectrum. Without the cosmological principle, we would be lost. Not poetically lost, scientifically lost. So the disappearance of the center is not a loss. It is the very foundation of our ability to understand the cosmos at all. Now let us consider time. The age of the universe is approximately 13.8 billion years. This number is derived from multiple independent measurements: the expansion rate, The temperature of the cosmic microwave background. The abundance of light elements forged in the first few minutes after the Big Bang. But what does it mean to say the universe is 13.8 billion years old if there is no center? It means that everywhere in the universe shares the same age. The expansion began simultaneously at every point. The cosmic clock started ticking at the same moment for every location, because every location was the same location before the expansion spread them apart. This is another gift of the centerless cosmos. Time is universal. The age of the universe is not measured from a special point. It is measured from the shared origin that every point contains. Your location in the universe is 13.8 billion years old. So is every other location. The beginning is not somewhere else. The beginning is woven into the fabric beneath your feet, encoded in the microwave radiation that fills every cubic centimeter of space, humming softly at a temperature of 2.725 kelvins. You are standing in the aftermath of the Big Bang right now. So is everyone. So is everything. Now let us consider the future. If the universe has no center, what does that mean for where we are going? The expansion is accelerating. This was discovered in 1998 by two independent teams studying distant supernova, the catastrophic deaths of massive stars, which briefly outshine entire galaxies and can be used as distance markers. The supernova were dimmer than expected. The galaxies hosting them were further away than the standard expansion rate predicted. Something was pushing the expansion to speed up. That something was named dark energy, a placeholder term for a phenomenon we observe but do not understand. Dark energy constitutes roughly 68% of the total energy content of the universe, and its effect is to make space expand faster and faster over time. In a universe with no center, the acceleration happens everywhere equally. Every point recedes from every other point at an increasing rate. Galaxies that are currently visible will, in the far future, cross beyond our observable horizon and vanish from sight. Not because they are moving through space faster than light, but because the space between us and them is growing faster than light can cross it. This means the observable universe is shrinking, in a sense. Not in size, it will continue to grow for a long time, but in content. The number of galaxies we can see, communicate with, or ever reach is decreasing with every passing moment. In roughly 100 billion years, a hypothetical astronomer in our galaxy, or whatever our galaxy has merged into by then, will look out at the sky and see nothing. No other galaxies, no cosmic microwave background, no evidence that the Big Bang ever happened. They will live in a universe that appears to be a single galaxy surrounded by empty, static darkness. And they will have no way of knowing it was ever otherwise. This is not alarming. It is simply the trajectory of an expanding, centerless cosmos. It is what happens when there is no anchor, no fixed point, no middle to hold things together. Everything drifts, slowly, gently, inevitably. And here is where the stakes become personal. We live in a window, a brief, luminous window in cosmic history, during which the universe is old enough to have formed stars, planets, and conscious beings, but young enough that we can still see the evidence of our origins. The microwave background is still detectable. The distant galaxies are still visible. The expansion rate is still measurable. The story of the cosmos is still legible, written across the sky in light and radiation and redshift. But that window will close. Not soon. Not in any human lifetime or any civilization's lifetime. But eventually, the universe is not hiding its secrets from us. It is showing them to us right now, in this era, in this sliver of deep time when the evidence is still available. And the deepest of those secrets, the one we have been circling all night, is that the universe has no center, and that this absence is not emptiness, but a kind of fullness. A fullness in which every point matters equally. A fullness in which the view from here is just as complete, just as rich as the view from anywhere. But we have not yet asked the hardest question. We have said the universe has no center. We have shown why the physics demands it, why the observations confirm it, why the myths about it persist, and why they fall apart under scrutiny. But we have not yet asked what replaces it. If there is no center, what is the shape of the universe? What is the geometry of a space that has no middle, no edge, and no boundary? What does it look like from the outside, if there even is an outside? These questions are not abstract. They have answers, partial, provisional, strange, and beautiful answers that push the human mind to its very limits of spatial imagination. And that is where we are going next, into the geometry of everything, into the shape of the shapeless. Rest a moment longer. Let the distances settle. Let the numbers fade to feeling. The next chapter asks you to see something no human eye has ever seen, and no human eye ever will. But the mind can go where the eye cannot. And it is almost time. Chapter 8. 3 shapes the universe might wear. We promised we would arrive at the geometry of everything. And now we are here. The question is simple to state, but strange to hold in the mind. What is the overall shape of the universe? Not the shape of galaxies, not the shape of solar systems. The shape of all of space, taken as a single object, considered whole. General relativity, Einstein's theory of gravity, tells us that the geometry of space is determined by the amount of matter and energy it contains. Mass curves space, energy bends it, and the total amount of curvature across the entire cosmos determines what shape the universe takes. There are 3 possibilities, just 3, and each one gives a different answer to the question of centers, edges, and boundaries. The first possibility is that the universe has positive curvature. Think of the surface of a sphere. If you walk in a straight line on a sphere, you eventually return to where you started. There are no edges. There is no boundary. But the space is finite. It wraps around on itself. A positively curved universe is closed. It contains a finite amount of space, but that space has no center and no edge. Just as the surface of the Earth has no center, you cannot point to a spot on the globe and say this is the middle of the surface. A positively curved universe has no middle either. You could travel forever in a straight line and never find an edge. You would simply loop back, like a ship sailing around the world. This model is elegant. It resolves the center problem beautifully, but it requires a specific density of matter and energy, and current measurements suggest the universe does not quite have enough to close itself in this way. The second possibility is negative curvature. Think of a saddle shape, or the inside of a trumpet bell, curving away from itself in every direction. A negatively curved universe is open and infinite. It expands forever, in every direction, without boundary. In an infinite universe, the absence of a center is almost self-evident. Infinity has no middle. Every point in infinite space is equally far from the non-existent edge. This model fits some of the data, but again, the measurements are not quite right. The universe does not appear to have enough negative curvature to match this geometry either. Which brings us to the third possibility, and this is the one that current observations favor most strongly. Flat. A flat universe is one in which the rules of ordinary geometry apply on the largest scales. Parallel lines remain parallel forever. The angles of a triangle add up to exactly 180 degrees. Space does not curve back on itself, and it does not flare outward. A flat universe can be infinite. It stretches in every direction without end. No edge, no boundary, no center, just space extending uniformly, populated by galaxies and radiation and dark matter and dark energy. The same everywhere, in every direction, forever. Current measurements from the Planck satellite, which mapped the cosmic microwave background with extraordinary precision, indicate that the universe is flat to within a margin of error of less than 0.5%. This does not prove the universe is flat. It proves that if there is curvature, It is so slight that we cannot detect it with our best instruments. But flatness is the leading model. And flatness, combined with homogeneity and isotropy, gives us a universe that is either infinite or so unimaginably large that the difference between finite but enormous and truly infinite is, for all practical purposes, meaningless. In any of these three geometries, closed, open, or flat, there is no center. The mathematics forbids it. The observations confirm it. The theoretical framework that underlies all of modern cosmology was built from the ground up on the assumption that no point in space is privileged. But here's where it gets interesting. Each of these shapes is a solution to Einstein's field equations under the assumption that the universe is perfectly smooth and uniform. The real universe, of course, is not perfectly smooth. It has galaxies and voids and filaments and walls. On small scales, the universe is lumpy, beautifully, intricately lumpy. Stars clump into galaxies. Galaxies clump into clusters. Clusters arrange themselves along vast filaments of dark matter, separated by enormous voids where almost nothing exists. This cosmic web, this intricate lacework of matter and emptiness, is the true structure of the universe on scales of hundreds of millions of light years. And within that web, there are structures so large they challenge the cosmological principle itself. The Hercules Corona Borealis Great Wall, identified in 2013, is a concentration of gamma-ray bursts spanning roughly 10 billion light-years. If confirmed, it is the largest known structure in the observable universe. Structures this large raise a quiet question. At what scale does homogeneity actually begin? How far do you have to zoom out before the universe truly looks the same everywhere? The standard answer is that homogeneity emerges at scales above roughly 1 billion light-years. Below that, structure dominates. Above it, smoothness prevails. But the existence of structures approaching 10 billion light-years in size presses against that boundary. It does not break it, not yet, but it leans against it in a way that keeps cosmologists alert. These are not cracks in the foundation. They are refinements. They are the places where the map is still being drawn. And they are the reason new instruments matter so much. Chapter 9. The new eyes opening on the sky. The James Webb Space Telescope floats at a point in space called the second Lagrange point, roughly 1.5 million kilometers from Earth, on the side opposite the Sun. It arrived there in January 2022 after a journey of 30 days. Its primary mirror spans 6.5 meters, composed of 18 hexagonal segments coated in gold, each one aligned to a precision of less than 1/10,000th the width of a human hair. Webb sees in infrared. It detects the heat of ancient galaxies, whose visible light has been stretched by the expansion of space into wavelengths our eyes cannot perceive. And in its first years of operation, it has already begun to challenge our understanding of cosmic history. Webb has found galaxies that appear too massive, too mature, too fully formed for their age. Galaxies that existed only a few hundred million years after the Big Bang, yet already contain billions of stars arranged in orderly disks. Standard models predicted that galaxy formation would be slower, messier, more gradual. The early universe was supposed to be chaotic, a turbulent fog of gas and dark matter only beginning to coalesce. Instead, Webb sees structure. Early, abundant, unexplained structure. This does not overturn the Big Bang. It does not restore a center. But it does tell us that the processes by which matter organized itself in the young universe were faster and more efficient than we assumed. The universe was in a hurry, and we do not yet fully understand why. Webb is not the only new instrument reshaping our view. The extremely large telescope, currently under construction in the Atacama Desert of Chile, will have a primary mirror nearly 40 meters across, the largest optical telescope ever built. When it sees first light, expected in the late 2020s, It will be capable of directly imaging exoplanet atmospheres and resolving individual stars in galaxies tens of millions of light years away. It will also refine our measurements of the Hubble constant, the rate at which the universe is expanding, which is currently the subject of one of the most puzzling disagreements in all of cosmology. The Hubble tension, as it is called, is this. Two different methods of measuring the expansion rate give two different answers. Measurements based on the cosmic microwave background, using data from the Planck satellite, yield an expansion rate of approximately 67.4 kilometers per second per megaparsec. Measurements based on nearby supernova and Cepheid variable stars, calibrated through a series of distance steps called the cosmic distance ladder, yield a rate of approximately 73. These numbers do not agree, and the disagreement is statistically significant, too large to be dismissed as measurement error. Something is wrong. Either one of the methods has a subtle flaw we have not yet identified, or there is new physics at work, some feature of the universe that our current models do not account for. The Hubble tension does not point toward a center, but it does suggest that the expansion of the universe may be more complex than we thought. The simplest models may need revision, and revision is not failure. Revision is how science breathes. Beyond light, new kinds of observatories are opening entirely new senses. Gravitational wave detectors LIGO in the United States, Virgo in Italy, Kagra in Japan. Listen for the ripples in spacetime caused by colliding black holes, merging neutron stars, and other cataclysmic events. These ripples travel at the speed of light and carry information about the universe that electromagnetic radiation cannot provide. They pass through dust, through gas, through the opaque fog of the early universe that blocks all forms of light. In the future, space-based gravitational wave observatories like LISA, planned for launch in the 2030s, will detect the merging of supermassive black holes across cosmic distances, providing a completely independent way to measure the expansion rate and the geometry of space. And then there are neutrinos, ghostly particles produced in nuclear reactions inside stars, in supernova, and in the Big Bang itself. Neutrino detectors buried deep underground, in ice at the South Pole, and beneath mountains in Japan and Italy, are slowly building a picture of the universe that no telescope can see. The cosmic neutrino background, a relic of the universe when it was only 1 second old, predates the cosmic microwave background by nearly 380,000 years. If we could detect it clearly, and current technology is not yet sensitive enough, it would give us a snapshot of the universe at an even earlier age, pushing our observational horizon back toward the very first moments of time. Each of these instruments asks the same question from a different angle. Is the universe truly homogeneous? Is the expansion truly uniform? Is the geometry truly flat? And each, so far, returns a variation of the same answer. Yes. To a remarkable degree, yes. But with footnotes. With asterisks. With anomalies that hum quietly at the edges of the data, like a note slightly out of tune in an otherwise perfect chord. The axis of evil in the microwave background. The cold spot. The Hubble tension. The unexpectedly mature galaxies in Webb's deep fields. The impossibly large structures in the cosmic web. None of these anomalies proves the universe has a center, but together they suggest that the universe is more textured, more layered, more nuanced than the simplest models allow. And that is not a problem. That is an invitation to look more carefully, to build better instruments, to ask more precise questions. The universe is not withholding its answers. It is waiting for us to learn how to ask. And the question we have been asking all night, does the universe have a center, is about to receive its fullest, most careful answer. Let the instruments rest. Let the data settle. The answer is near. Chapter 10. The quiet truth at the heart of nowhere. We have come a long way tonight. We began with ancient astronomers, placing Earth at the center of everything. We watched Copernicus move the center to the sun. We saw Shapley move it again, to the heart of the Milky Way. We watched Hubble dissolve the boundaries of our galaxy entirely and reveal a cosmos of billions of galaxies, all receding from one another. At each step, the center moved, and at each step, the universe grew larger. But the final step is not another relocation. It is an erasure. The universe has no center. And now we can say precisely what that means. It means that the Big Bang did not happen at a point. It happened everywhere. Every cubic centimeter of space that exists today was present at the beginning, compressed into the hot, dense, uniform state from which everything expanded. There is no place you can point to and say, it started here, because it started everywhere. The beginning is not located in space. The beginning is located in time, 13.8 billion years ago. That is where the center is, if the word center means anything at all in this context. Not a place in space, but a moment in time. A moment that every point in the universe shares equally. The center of the universe is not a where. It is a when. And that when is the same for everyone, everywhere, in every direction. This is the revelation we have been building toward. The universe does not have a spatial center because the Big Bang was not a spatial event. It was a temporal one. The expansion of space began at a moment, not at a location. And because it began everywhere simultaneously, no location can claim priority. Let that settle. The center is a moment, not a place. And that moment is shared. This is what the cosmic microwave background tells us. That ancient glow, that faint hiss of radiation filling all of space at a temperature of 2.725 kelvins, is the afterimage of the moment the universe became transparent to light. It is the same in every direction, because the origin was the same in every direction. When you tune a radio between stations and hear static, a tiny fraction of that noise, about 1%, is the cosmic microwave background. You are listening to the birth of the universe, and it is coming from everywhere at once, because it happened everywhere at once. No center, just the shared hum of a common beginning. This is what general relativity predicts. In a homogeneous isotropic universe governed by Einstein's equations, the expansion is uniform. The metric, the mathematical object that describes the distances between points in space, stretches equally everywhere. No point is privileged. No location is the origin. The equations do not contain a center term. There is no variable for it. It is not that the center is hidden or unknown. It is that the mathematics does not have a place to put one. This is what the observations confirm. The galaxy surveys, the redshift measurements, the microwave background maps, the supernova distance data, all of it is consistent with a universe that is the same everywhere, expanding equally from every point with no preferred location. And this is what the anomalies do not contradict. The axis of evil, the cold spot, the Hubble tension. These are refinements, not reversals. They may eventually teach us something new about the topology of the universe, about the nature of dark energy, about the physics of inflation. But none of them have produced evidence of a center. The center is absent, not lost, not hidden, not awaiting discovery. Absent by structure, by mathematics, by observation. And here's the part that matters most, the part we have been saving for last. This absence is not a void. It is not a vacancy where meaning used to be. It is a feature of the cosmos that, once understood, offers something no center ever could: the quality, true, structural, inviolable equality of place. No location in the universe is more central than any other. No galaxy is closer to the origin. No civilization, however advanced, however ancient, occupies a more privileged position in the cosmic architecture. The view from here, from Earth, from your room, from the precise point in space where your body rests tonight, is exactly as central as the view from anywhere else in the universe. You are at the center, and so is everyone else. And so is every point in the void between galaxies where no one has ever been and no one ever will. This is not a consolation prize. This is the actual structure of reality. The universe does not rank its locations. It does not assign importance by coordinates. It offers the same physics, the same expansion, the same microwave background, the same laws to every point equally. And in that equality, there is something very close to grace. Not religious grace, not supernatural grace. The grace of a system that does not play favorites. The grace of a cosmos in which your position is neither blessed nor cursed, neither central nor marginal, but simply and fully part of the whole. The ancient astronomers were not wrong to look for a center. The desire for one is deeply human. But the universe, in its quiet, mathematical way, has offered something better than a center. It has offered a structure in which the center is everywhere, or, if you prefer, nowhere. And those two statements, paradoxically, mean exactly the same thing. The universe has no center, and therefore, you are at the center of the universe. Both of these sentences are true. They are not contradictions. They are the same truth, spoken in two different tones of voice. One is the voice of physics. The other is the voice of rest. And both are telling you the same thing tonight. You are exactly where you belong. The night continues, as it always does. Somewhere above you, beyond the ceiling, beyond the atmosphere, beyond the orbits of the planets, the universe is expanding, slowly, silently, in every direction at once. No center pulls it inward, no edge contains it. It simply stretches, carrying its galaxies and its ancient light and its unresolved mysteries outward into more of itself. The cosmic microwave background hums at 2.725 kelvins. The gravitational waves ripple through spacetime like the memory of collisions no one witnessed. The neutrinos stream through your body, 100 trillion of them every second, carrying information from the hearts of distant stars. You feel none of it, and that is fine. You do not need to feel it to be part of it. The atoms in your body were forged in stars that died before the Earth existed. The hydrogen in the water on your nightstand has existed since the first few minutes after the Big Bang. You are made of the universe, and the universe has no center. And so you are made of something that belongs equally to everywhere. There is no place more important than where you are right now. There is no cosmic address more valid than the one you already hold. The universe has no center, and in that absence something opens, a space without hierarchy, a darkness without threat, a quiet so deep it hums. Let it hold you. You have traveled far tonight, from ancient Greece to the surface of a balloon, from Copernicus to the cosmic web, from the cold spot to the shape of everything. The question has been answered. The center is a moment, not a place. And that moment is shared by all things equally. Rest now. The expansion continues, and it asks nothing of you. If this journey brought you peace or wonder or a gentler kind of sleep, you are welcome here again. Subscribe to Science Asleep, and let the next journey find you when the night is ready. The universe will still be expanding when you wake, and you will still be at the center of it. Good night.